how are we doing? It is the start of office hours, and we're gonna do a lot of work today. Watsky said, you gotta work. He says, till your arms fall off. Then we're not gonna do that. We're gonna stop short of arms falling off. So we're gonna do some work. I'm gonna get into my Pearson up and going right now. My Pearson up in here. And how's everyone doing? Feel free to say hi in the chat. If you're here. If you're not here, don't say hi, because then you're not here, so you won't be able to say hi. Mubot is in the chat. So say hi to Mubot. He gives points out to those who are here. And I'm gonna get to my Pearson up as we talk. Want to do all of my Pearson. Hey, Winnie, good to see you here. I'll throw you some points. Points in the chat. Do you have any questions on the my Pearson? Be like, how do I do such and such question? Maybe I should have said hi. Oh, you did the exclamation. Hey, Carol, good to see you here. Do you have any questions on the material? I think everyone's current students, right? I even said hey to, I did the wrong password on Pearson. Whoops. Whoops. Be like, hey, Brian, how do we do this question? How do we find the mean? How do we find the standard deviation? What does this question mean? Just give me the start of a question if you want. Almost got my Pearson up and going. Disappear. Reappear. Back. And my Pearson assignment manager. How's everyone doing this morning? Carolyn, Winnie, how are you doing? I say guys for everybody. I was gonna say how you guys doing, but I don't know. I'm from New York. Everyone's guys. I walk in, see my grandparents. I'm like, hey, how you guys doing? They're like, you're weird, Brian. Yep. We're gonna get going here on chapter 2 quiz. Got it up on the screen. Try to do some more difficult ones, challenging problems. Doing well. It's been a nice day so far. Nice relaxing day. And yeah, I'm excited because it's Monday, Wednesdays are nice. Here we go. Doing great. That's awesome. We'll throw some more points. Let's go check out a question right here on the main screen. Let's go do it. Main screen. What's up, Charlie? Good to see you, Charlie. What are you up to these days? What classes you taking? I know Charlie right there. I guess, Charlie, did you take 2019, 2020? Oh my gosh, how many? Charlie, so good to see you. Hope you're doing well. Reach out if you're working at a company. Come back, recruit students, say hey to them. Charlie, good to see you. Hope you're doing well. We're throwing Charlie some points. Still a mod, graduated and working now. Congratulations, Charlie. That is so good to hear. Hope you're having an awesome time working and using your skills. We're still teaching skills here at Stat 201. We're gonna do some of the hardest questions. There's 28 questions. Oh my gosh. You can start at the beginning, just start marking through questions, do the easy ones, do the hard ones. So, you know, people can come back, check out this video later. But Charlie, we're throwing 100 points. I don't get to see Charlie much. Thank you for swinging by. Maybe somebody posts on the Discord if you're still in the Discord, which is awesome. And if your company ever wants to recruit here, come in and recruit. We love when people recruit our students. Okay, so what do we have here to start? We're gonna mark this question 653, and this is the table to the right. Now, if you're wondering what I'm doing, I always mark where the questions are at in the video. So that way I mark the first start of it, and I need to say chapter, so this is Stat 201, and it's chapter 2 quiz, the table to the right. So that way people can come back and reference what we're doing, and you're probably watching this now in the future if you've clicked on this. This one's not so bad. You need to know what you're looking at, though. This is a frequency table, and they want you to turn it into a relative frequency table. Let's do that one next. You got it, Caroline. We'll do this one pretty quickly right here, and then we're gonna do that one next. Thank you, Caroline. 50 points for just asking that. We'll do it next. You got it. So knowing the difference between a frequency table and a relative frequency table, write this down if you don't have it. Frequency tables are categorical univariate displays of data, which means we're displaying one categorical question. Relative means it's as a percent. So the question here was, what kind of car do you drive, I think, is compact, subcompact. That's a categorical question. Even though these are numbers, the question was, like, if you say, Brian, what kind of car do you drive? I drive a sedan, I guess. I don't know. I drive an intermediate car, I guess. And so, oh, number of passenger occupants. Oh, well, that's horrible. Anyways, we'll just say it's the type of car people drive. Better than the question. And now what you do is you first need to find out the total amount. So we're going to take right here how many total cars there are. Then we're going to add. So the problem with this one, this is just laborious. It's just a bunch of math. And if you do a math error, you lose the question. You don't get the points. So it's 13,504. And we just need to divide all the numbers by the total. So to turn frequency to relative frequency, divide each one by the total. So we're going to take this 1729, divide by that, and then we're going to turn it to percentage 1280. And then we divide the next one by the percentage. And you know what we're going to do? We're going to make this a little smaller. We can look at it at the same time. There we go. And I'm going to disappear off the screen. And then you got it, Caroline. We're going to do that one next. 3522 divide by the total, because I added up the total, times by 100, 26.08. Next one right here, we're going to do 4937 divide by total, 3656. And what you could do is you could add these up afterwards, make sure they add up to close to 100. Sometimes due to rounding, it doesn't add up perfectly because sometimes one rounds up and one rounds down. You get a little bit of a weirdness. Like I think that's 22.22. Yep, looks to be. And the 316 divide by this. That's 2.34. So as long as you don't make a math error, you should be good. And we got it correct. And I think that's it for that question, 100%. So Caroline, let's do your question right here. How do you find this question? The interquartile range is IQR equals. So the interquartile range, is that the start of the question, Caroline, right there? Is that the very start of it? Like if it says a study on body fat or something, let me know that. I'm gonna look for it right here. Tell me the very start of the question. That might be it right there. And then I'll look for the very first few words of it. That's the easiest way for me to find it. It's the last part. How does it start? What does the question start with? Thank you, Caroline. Keep asking things. Throw you some points right here. What does the very start of it say? How does the question start? What are the first few words of it up here at the top? And then because that's why I put in the thing too. First two words. This one looks like an ass talking about interquartile range up down there. And a good thing, no. Well, I guess I'll start teaching when we do the segment right here, but I'll explain what oh, wait. Here we go. No, that's about IQRs, but we'll see it. Trying to find it. That one, did you see the number of it? Tell me which number. Sometimes we're on a delay. Is it this one right here? If you saw 22 or 23, if you say the number, and then I'm going to mark the time right here as you tell me the number, or it'd be yes, this one right here. You tell me the number. We can just do whichever ones you want. See you, Charlie. Have a great day. Is it this one right here, Caroline? Is it number 22 or 23 rather? Stat 201, chapter 2, quiz 22. Oh, 22. Boom. Thank you, Caroline. Here it is right here. And let's mark the question and the histogram to the right. And this is about the IQR. Okay, let's talk about this right here. This is a histogram. A histogram is a display of univariate quantitative data. Make sure to have notes like this. A histogram is univariate quantitative data. That's something you want to write down and know. Put it on a flashcard. Flashcard, here's your flashcard. Histogram, univariate quantitative data. Rather, here's more like a flashcard. So histogram, univariate quantitative data. And that means we're displaying one quantitative question. And this question was, what is someone's neck size? What is the neck size? So they took a measuring tape around someone's neck, found the measurement. Maybe they're wearing a collar or something like that. And so now we have neck size right here. So, collared shirts, got to get it right. Should we try and do the homeworks in the jump before? You could tell me whichever one you're working on. We could also do jump here if you want to. Good questions, Alexander. We'll throw you some points. Now, what is the IQR? What is the IQR? The IQR stands for the interquartile range. This means if I have data and we were to divide the data into quarters, it would be the interquarters. The interquarters exist here. These are the interquarters. The interquarters make up what percent of the data? The interquarters make up what percent of the data? The interquarters make up what percent of the data? The inter ones, not the outer. They make up the same amount. But the interquarters make up what percent of the data? If you had a bunch of data below here, like you had people who gave you their push-ups, everyone's doing one push-up down here. 1, 1, 2, 2, 2, 3. This is made up data. 50%, great job, throw more points. Avalon, good to see you here. So the interquarter range is the range of the middle 50% of the data. And I've got here about the interquartile range is about from here to here maybe. So it might be like from 1.5 to about 3. So the interquartile range has a range of 1.5. I'm just kind of guesstimating it. Actually, that does look kind of right-ish. It's if you look, there's about it's close. It's close to the interquartile range. We could put it into a software and have it find us, but it's the range of the middle 50% of the data. How far away is the middle 50%? So you'd have to go to the middle 50% and look at its distance from itself. One last example, and this might work better if I show it in jump right here. So let me put up this screen right here and I'll show it in jump so we can see what the interquartile range looks like, because you need to know what we're talking about when we say the interquartile range is, let's do 10 observations right here. So we're going to ask people a question like, how tall are you? And you put them in order. And you have to think, where would the interquartile range be? So the interquartile range is the range of the middle 50%. So if you had 10 observations, you'd look at the middle 5 or so right here. It's going to be about from 64 to 68. So now we're guesstimating it. Software will find it for us. So tell me, the middle 50% of the data has a range of about what? I want the range of it. How far away is this? The middle 50% of data, all I want you to do is tell me how far away are those numbers. Nothing too complex here. How far away are those numbers? How far away are those numbers right there? So I'm showing you about where the middle 50% is. Software is going to find it exactly for us. That's about the middle 50% of the data. So how far away are those numbers? That's what the interquartile range is. Because we're asking, what is the distance these numbers are away? The middle 50% has a range or distance this far away from itself. So what is the interquartile range as I lag behind in time? For Caroline, more points in the chat right there. Great work. And so we won't find this one by hand. You'll never find it by hand on the test. What you'll do instead is you'll go over here and look at output. And if you notice, this is using decimals now. It's kind of close-ish to 4. You would take the 75th minus the 25th. So you'd go 69 minus 63.75, and it's actually 5.25 exactly. Why is it the middle? Is that the middle 50%? So we're not going to find it by hand. That's the good news. Software is going to tell us where the 25th percentile is, and I'm going to bring it a little further over here so I can point to it. Software is going to tell us where the 25th and the 75th percentile is, and all we have to do is what these two numbers. So these two numbers right here, where the 25th and the 75th percentile are, all we need to do is what the difference between these numbers are do what right here. And because that's where the 75th percentile is, this is where the 25th, this is the middle 50%. What do you do to these two numbers to find the IQR? I've got the math shown on the calculator over here. What do you do? So you can look over the calculator to cheat. Find that's what the interquartile range is. It's how far away is the 25th percentile from the 75th. You can kind of see it and estimate it by looking at where the middle 50% of the data is. We'll never do it by hand. We'll use software. The middle 50% of the question right here is probably somewhere in here. Like that's where the middle 50% of the data would be, like somewhere around the middle where 50% of the observations would be in the middle. Once again, we'll look at output to find this. So this one actually wants to know the proper center and spread. This goes back to our lecture right here. When doing center and spread, you must first know the what. Before doing center and spread, this is a huge thing. This is test relevant. Before doing center and spread, you must know the what, and write this down. You must know the shape. Avalon, more points in the chat. You must know the shape. So if you choose a shape, if you say your shape is more normal, then your proper center is going to be more mean and standard deviation. If you say it's more skewed or outliers, then you're going to have median and IQR. So the only task for us right now is to determine the shape. Let's go look at the shape. Does this look normal or skewed? What do you think? Now, outliers, we want to look for some pretty extreme outliers. I know there's a little bit on there. Does this look normal, like unimodal symmetric? That's what normal means. Or does it look kind of skewed? It looks normal. Caroline, great job right there. So since this looks normal, remember, we already have written down which way we're going to go. If it goes the normal path, we're going to go mean for center. That's going to be the measure of center. And then standard deviation is going to tell us how things spread. So the mean is standard deviation because it's unimodal and symmetric. Boom, I think that should do it right there. And this is a great question. This is very much like a test question. So Really good to know that and why it's the answers, because the shape determines the proper center and spread. Really good question and a lot of good review in this right here. So ask another one. Can you also do the question, the data in the accompanying table? You bet. Let's do it. Just keep dropping those questions. The data in the accompanying table. Let's do it. Thank you, Caroline, right here. A little chill music while we get started on it. The data in the accompanying table. Just drop the next one and just be like another one. Where is it at? There we go.
Wow.
I like it. Now my Pearson, don't break my Pearson. Don't do this. Don't you break my Pearson. It'll be right at the end, isn't it? The data in the accompanying table. Let's mark this. We can come back to it later. We might be able to do like all the quiz, pretty much everyone, but keep doing the ones you want right here. And we're going to review the concepts to make sure people understand more than just how to solve the question. I want to get you ready for the test, and I will mention things that are important for the test. The data in the accompanying. There we go, misspelled it. Okay. So what do we have right here? It's going to be data. Okay. Now I want you to look at this. A lot of the data is 2 digits. And then you see that. That very much looks like, are we supposed to? I'll show you how to do that next, Winnie. You got it. That'll be the next thing. Stay tuned. So with this right here, that 555 definitely looks like a what? Imagine this is how many miles people have run in a week. And someone says, I've run 41 miles, 61 miles. And then someone's like, I've ran 555 miles in a week. That definitely looks like a what? That definitely looks like a what? Does it look extreme? Does it look far away from the rest of the observations? Do we have a word for that? Are there any other values that are close to it? It's an outlier, and there's a huge gap. We can go make this visually here, and how would we visualize it? Caroline, amazing work on all this. That's an outlier just looking at the data. It's far away from the rest of the observations. What are some visualizations I can use for this? I don't think we have to do this. I'm gonna show you how to do it. We're gonna copy to clipboard. And once we hit that button there to copy to clipboard, we hit Control-C or Command-C, depending on Mac or PC. We go over here to Jump, and inside of Jump, we go to File, New, Data Table. File, New, Data Table. Under File, New Data Table, don't click inside of it, go to Edit and Paste. This did not have column names, I don't think, so we're just gonna paste. If it has a column name at the top, paste with column names. So notice it says column 1, that's good. If you pasted with column names, it'll put the first observation in the column name because that's probably the column name. So watch out, don't make this error right here. Make sure it has the observations in the rows and not the column name. Be very careful. Sometimes the paste is where people make a mistake. What visualization would we have for this? This is something about hurricanes or something, is it? This is flood deaths, fun topics for today. So what visualizations could we make this quantitative data in? So tell me a visualization for this. So look at this graphic I have on the screen and tell me a visualization for univariate quantitative data. A visualization for univariate quantitative data. Good review. How can we visualize univariate? How can we like display it to people? Like be like, oh, look at this graphic. We could make a what graphic? What graphic could we make? Look at this graph. Make. Not blocking any answers, hint. Don't worry about getting it wrong. If you understand how to look at this right here, you can say, okay, it's univariate quantitative. You throw points for right or wrong answers. Univariate quantitative. What are the graphical displays or possibilities for univariate? That means one variable. Quantitative, that means a question like how much, like how tall are you? How much money did you spend? Alexander, I'm throwing you 100 points right there, Alexander. Bar chart is a wrong answer, but it got everyone 100 points. Bar charts are for categorical data, about 100 points right there. So don't worry, keep getting those points. And histogram is probably our top choice. Dot plots aren't bad. We're in this region right here. Univariate quantitative bar charts are univariate categorical. Notice how there's nothing all the way over there where I disappear because there's no extra variable. This is univariate quantitative. This is univariate categorical. Bivariate quantitative, bivariate categorical, and a mix of cat quant right here. So good answers in the chat. Dot plots right there. Dot plots are an answer. I'm not a big fan of them, but hey, you can make them if you want. So I'm going to go here to analyze distribution. Under analyze distribution, we're just going to double click the variable of interest or click the Y columns. Either one does it, and then we click OK. Now you can see we have a histogram and a box plot on top. Click the top right arrow and click stack. This just puts it in horizontal layout, and I'm going to stretch it out right here so you can see, and we have the histogram and the summary statistics, and things like the IQR can be found right here. If you don't want to find the IQR by hand, by subtracting 41.5 out of 105, which is 63.5, you can click this arrow here, go to Customize Summary Statistics. Under Customize Summary Statistics, go to the interquartile range, and then click OK, and there's the 63.5, which is the distance of 105 to 41.5. In other words, JUMP can find all the answers for you. So the distribution of floods is definitely, and we got to say hey to him, he's our best friend. This is definitely either skewed to the right or skewed to the left. So what way is this distribution skewed? Can anyone tell me in the chat, what way is this distribution skewed? What way is this distribution skewed? Who knows in the chat? Right, great job right there. We only throw 20 points for right answers. It's right to the high, left to the low, whatever way the monster man's tail goes. Right to the high, and that's positive skew. Left to the low, that's negative skew. And just remember, right to the high, left to the low, whatever way the monster man's tail goes. There's monster man right there. There's his tail. It's pulled to the right side, the high side, often known as positive skew. So right to the high, left to the low, whatever way the monster man's tail goes. So love that one. That's the one I made up. There's a few things students have made up that I've stolen or used, borrowed. But it's definitely right skewed, 100% right skewed. And there is an extreme outlier. It's unimodal, as in there is one peak and there's an extreme 555. So when you put it into JUMP, you can definitely see it has that one mode to it. Unimodal means there is one centrality of the data. You've probably heard the word mode before, which means most often, but modal means kind of concentration of data. And things that are bimodal have two concentrations of data. Multimodal means multiple, so that is technically multimodal right there. So now we should have the right answer. We got it. Let's do the how to take random sample. Just a quick talk on this. And please let me know if you have questions. So stat 201. No, you don't have to learn it. That's really good questions right there. Analytics number one. So here's the thing, Alexander, right here. Really good stuff. Check this out. I've got the visualization playlist in the chat right now. So we're going to talk about kind of my tips and tricks for the visualization assignments. So here is my visualization playlist. And if you go through this, you can even go down to the really fun ones. Oh no, this one's not it.
And I thought my jokes were bad. Ladies and gentlemen, we are tonight's entertainment. Learn to do these visualizations.
I like that part right there. I don't know. Back in the day when I dressed up as the Joker, you never know. Got to grow the hair back out to make it work. But I don't know. That's like that right there. I was like, yes. Did like so many takes of this. Anyways, so I have some fun with these. Check them out. Hopefully they're entertaining and also informative. That's kind of my goal, is for you to have some fun. But the visualization playlist, if you're watching this right now, is in the chat, and it has a walkthrough for each one. Now, I'm not just going to leave you with that because we're here to teach right now, but check out the visualization playlist for a lot of help. Also, I have a JUMP playlist. How do you find the summary of data from just the sheet of JUMP? Let's show that too right here. So there's the JUMP playlist right there, which has additional videos showing how to do these things. So you can click right here, the JUMP playlist, and it's got a bunch of installs, histograms, stem and leaf, pie charts, all these different things. So the one you'd want to go to right now is going to be, do I have right here, histograms and stem and leaves. So right here, the histograms and stem and leaves, because histograms are quantitative displays of data. You'd click this one right here, and this is a 1-minute video. There's no fun in this video. It just shows you the data, and you've got your quantitative data right here. And so there's a quantitative row of data. What you'll do right here is you'll go to Analyze. I'll be doing it here in a second. I'm showing it's quantitative because it's blue. Analyze Distribution. After you do Analyze Distribution, you double-click the variable of interest. Once you do that, it goes into the Y columns, which is the variable you want to display. You click OK. I always click the red arrow at the top to stack it. I've been doing that for years, so of course I'll do it in this video in the past. That puts it in horizontal layout. From here, you can add things like count axes, you can color the histogram, you can change the bin widths, which I'm doing right now. But these videos right here are a nice, slow, methodical explanation. Do I add? I do a stem and leaf. Yay, stem and leaves. But you should add a count axis to it also, which I guess, do I not add in this video? I just mentioned how it's the stem and leaf and the histogram show you the same data. Like it's still the same observation that 54 can be seen in the stem and leaf. Does that help right there, Caroline, with that one? And then we're going to talk about the data analytics. But for anything you're wondering in Jump, I usually have a video going over it, and I go nice and slow, and the videos are usually straight to the point. So check out the Jump playlist or the visualization playlist for videos directly on doing the visualizations. You're welcome, Caroline. What video title is that? This one right here is the histograms and stem and leaf plots found in the Jump playlist, where here is help with Jump, Newbot said right there. So click that playlist and you'll see all the different videos. So these are the Jump tutorials. There's 26 of them. Whether you want to take a random sample, whether you want to do decision trees, whether you want to do all different things, side-by-side box plots, tabulate. Tabulate's really good. I haven't used it in a while. Pie charts and bar graphs. Yeah, so lots of different videos on different things. I forget I made some of these. Changing variable types. Gosh, 410 views. No one's using that one. But I made a lot of these 1-minute videos where it was like, oh, people will love these. It'll be great. And then I don't get used. Anyways, I mean, yeah, 8 years ago. Oh my. Been a while. It's been a while. Okay. So with that, about the random sample, that's what started us down this path. So when you do your random sample, let me go open some data right here. And we're going to open up let's see the Pokemon. Gosh. Okay. I got 800 Pokemon right here. There's Bulbasaur, Ivysaur, Venusaur. Oh, Venusaur Mega or something. Mega Venusaur. So here is all the different Pokemon, because I guess a Mega counts as a different Pokemon than Venusaur. Technically, I guess in your decks too. Thank you so much, Sarah. You rock right there. And good to see you here. Probably saw it on the Discord. So Sarah, good to see you here. Getting everyone 50 points for being here. So to take a random sample and what you need to submit is the big question right now. So here's what you need to do. Go to table, then subset. Under table subset, you want to go ahead and type 400. I think yours is 400. Double check if you're watching this in the future. 400 plus the last two of your UTID. Mine's going to be 432. Make sure it's the last two of your UTID. And make sure the assignment says 400 plus the last two of your UTID. From here, we're going to click OK. Now we get the random subset of 432. Now I'm going to tell you how the graders grade this. When the graders grade this, you need to make sure you have a few things. Your name at the top with the section, with also, I think, the class, the name. I'm going to double check what you need. You need the information at the top. And for this one, you need a proper screenshot. So go to snipping tool on a PC or Command-Shift-4 on a Mac. You want to take from here down, because they're going to be looking for that 432. Go to a new Word document and paste the screenshot. This is how your screenshot should look, because when the graders are grading it, they are going to be looking for that right there. That's what the graders are going to look at. I guess you can technically highlight it. They shouldn't take up points if you do that, but I wouldn't highlight it, because then they get confused. They're like, why'd they do that? But that is what the graders are going to look at to see if you took a random sample size of the required sample size. Now, there's additional things we need, though. And I'm going to double check, because every once in a while, I'll say something that's slightly wrong. And I don't want to say anything that's wrong. I want to make sure you get all the points. And to get all the points on these assignments, you need to look at the rubric. So the rubric down here on the bottom tells you how you get your points. And so we're going to look at the rubric for how we get our points. You have to put your name, your UTK email, your instructor names, your section. Oh my, how much are we asking for at the top of the thing now? Oh my gosh. So let's grab this. Let's grab this right here. So we need all of this at the top. So we go over here and we grab this. We just drop that in. My name is Brian Stevens and my UTK email, bstevens@utk.edu. My instructor's name is myself. Do not put that. Only put if you're the teacher. Do not put that. And I am in, our section is like 004, but like online with Brian Stevens. You can put that. If you're in my class, look up your other ones, or we want to know, you know, your section is probably important if your teacher teaches multiple sections, but please put the things right here. And I'd probably say, even now I'm going to put spring 2024. There we go. That's really going to help us right there to identify like who's your teacher, what section, what semester, all this good stuff. And we should be good, because this is just to like know who's this assignment for, what's going on right here. And that should be everything. So let's see if we got all the other points. Here we go. We would now get full marks right here. Think about how the grader is going to do this. They're going to say, okay, they put everything right there. They put all the information about who's this for and what's their name. Was a random sample taken? Yup. Was a proper screenshot taken? Yup. And I'm going to look at that here in a moment where we don't do a proper screenshot. And then you completed the assignment. So your end product, to be very, very clear, this is what your end product is going to look like. Does that answer the... So this is the end product. I'm going to disappear. This is the end product. This is the data analytics one. And hopefully people aren't stuck on it. But this will be... If you're stuck, usually it's installing jump. You're not going to use the Pokemon data set. I used a different data set right here. So if someone turns this in, we'd be like, hey, that's not the Pokemon data set. We're not doing that. But you'll do your data set that the assignment has. I just did a different data set because just showing how to take a random sample. Additionally, a lot of mistakes happen when people turn in a bad screenshot. We see a lot of screenshots that look the following way and people lose points where they take a screenshot like this of the full screen. I'm off to work. Awesome. Sarah, more points in the chat. You're welcome. And we see this right here where people take screenshots that just show the full screen and don't do this. Click the image, go to picture format. And on picture format, go to crop, grab the little black bars down here, crop up here, crop that little edge there. I know that's being particular. We can even crop more because we only really need to make it look super nice. That left side doesn't have extra. Then crop out the top of the window right there. Subset, good right there, and then click away from it, resize it, and you have a great screenshot. So the key is you want your screenshot to look good and professional and show what you want to show. You can even, you don't have to do stuff like this, but you could add, don't make sure it doesn't block information. I've had people do like big borders like this that partially destroy the image. You don't want to do that. Like a nice border like that, just make sure it doesn't remove information. So if you add borders or anything to something, just make sure it doesn't destroy the information contained within. So if you have like a little extra around it, a board would actually fix that too. This is a nice professional, like it says what we need to say and the image is good. So turn it in like this. Okay, what other questions do we have? Drop those questions in the chat. We're still working away right here. What questions do we have? It's your office hours. Whatever questions you got. That's the data analytics assignments. I'm going to keep going through probably from the beginning. Might be able to do all of these. But just be like, hey, Brian, can you do this? Even if I'm working on something, just be like, can you do this? Can you do that? We'll just do it next. And here we go. Let's mark this one. 3703, stat 201. You do this, the data in the accompanying table are the annual deaths from tornadoes. You're welcome, Winnie. Good to have you here. Tornadoes. Tell me if you see the number as I do this right here. This is just, why are they just obsessed with people dying? Data. Floods, there's floods. There we go, here we go. Good one, good one. This is a tricky one. I bet a lot of people are wondering this. Sorry, some 50 points. Thank you for asking this one, Alexander. Bet a lot of people are wondering this one because this is a tougher one. So let's do it. Let's do this bigger question that's a little tricky. Let's get down. I'm gonna write down the question here in the timestamps so that people come back to this in the future. And this is, there was a thing on the screen. Chapter 2 quiz And the data, everything's the data in the accompanying table. And this is floods. Okay. So with this question right here, it's giving us a bunch of data, and we have to find what are called the summary statistics because they summarize the data into statistics. Statistics come from samples. And there's a sample of data of flood deaths. Looks to be, we got the extreme value again. Once again, your data will be different from mine. I hope people know that because I've had people put in my answers and then they say, well, it didn't work. We have to run your data. So we need to click the data first. If you saw, I did that. We can look at it, and it looks like there's some extreme values, outliers, and we need to now bring it into Jump by clicking the box right here. This allows us to copy to clipboard. Copy to clipboard by clicking it, and then hit Control-C on a PC or Command-C on a Mac. This is going to copy it to your clipboard in the background where it's holding it. Now that it's copied to the clipboard, bring it over to Jump. Yeah, Jonah, we can talk about that next too. Here's this playlist has it. Let me know where you're stuck on. We'll work on that next, Jonah. You got it. And so now we're going to go to File, New Data Table. File, New Data Table. They do change. We shine Blakely thank you for being here. And throw another question in here, Blakely. They change each time you do it. There's a mix of questions you can get. You get different questions each time. Sometimes you get easier ones. So using all 5 attempts, you might get some easy ones. I'm being serious. Like, people have been like, man, my quiz was easy. And someone's like, that quiz was so hard. And then you're like, oh, I got the easy version. You get lucky sometimes. Randomness, you never know. Now that we did File, New Data Table, we're going to go to Edit, Paste. Now, you need to look if there's a column name. There was not a column name for this one. I'll show you when there is one. Column names, just Edit, Paste. You'll see at the very top of it, there'll be a name. Actually, that does look like it has a column name, but apparently it doesn't. So you might have thought it did. If you pasted with column names, you'll see the first observation is now in the first column, and that is wrong because it tries to put the column name in the top column. So if you paste it with column names, you'll get this. It'll be wrong. If you pasted normally with just paste, edit, paste, you'll get the 21 observations right here. Now we need to go to Analyze Distribution. Analyze Distribution is going to create a histogram for us. We're going to double click the Y variable of interest, and it'll go into the Y columns because we're going to analyze the Y variable of interest. Clicking OK makes the histogram, which has a pretty good right skew to it. And so let's go right here, drag it out a little bit. And when you display data, it's very good. A lot of times this is not required, but to do things where you go and you just make your histogram a little nicer color, make it a light purple. There we go. You don't have to do that. You go right here and go to histogram options and go to count axis. You could even, I kind of like this shadow histogram thing, I think. Kind of cool. Or it is shadowgram. Whoa. That's kind of neat right there. Not required, but you can definitely see Monster Man. He looks like a Loch Ness Monster Man right there. That's a shadow histogram. Just kind of does like a density of where the data's at. And let's look at Loch Ness Monster Man over here. We got Loch Ness Monster Man with his right skew. And there's the little bump on the side right there, Loch Ness Monster Man. But we always say right to the high, left to the low, whatever way the Monster Man's tail goes. And this is sometimes called positive skew over here. This is negative skew. And if you ever don't know what way it's skewed, you can actually cheat by going over here, click the summary statistics and go to customize summary statistics, and then go to skewness, wherever skewness is at. Here it is right here, and click it. And if it's positive, it's right skewed. And this is very, very right skewed. Actually, no need to go jump. I'll go to, yeah, awesome. See you then, Jonah. We'll do it then. What did you click to get it to look like that? Mine has bars. And no worries. Here's the thing, Alexander. None of this is required right now. So we're just having a little bit of fun, but I'll show you. If you want to make it a shadow histogram, which is not required, it is found right there under the second red arrow, histogram options, shadowgram. Not required. Not required. The big thing that I want you to see though right now, just to remember, is that sometimes you'll hear people say positive skew, and here's the skewness over here. Positive skew means what direction it's skewed. So positive skew, if you ever hear anyone say it's positive skew means skewed to the what side? Because you'll hear us call it this. Positive skew means it's right skew. So when we have a positive skew, it's right skew. If it's zero, then it's symmetric. Zero skew means symmetric. Negative skew means left skew. that was what I wanted to review right there, just as a review before we answer these questions. Now, the good news is we probably have all the answers to the question now. Because it wants us to get the summary statistics, here's all the summary statistics. Additionally, we should know how to get the IQR. Now, what does the IQR mean? What does IQR stand for? These are the notes to take as we're talking about it. Like if you have quarters right here, your data is cut up into 4 quarters. The IQR would be the what's? Interquartile range. So these are the what quarters? These are the inner quarters. And the inner quarters would range from the 25th percentile to the 75th percentile. And then if you take a range, you just take the distance between those numbers. Range is max minus min, so this is big number minus small number. So if you look at your data right here, the IQR is going to be the 75th percentile minus the 25th. Now you can try to do this in your head right here, 184.5 minus 83, so we'd add 17 to that. So I might be doing it wrong, but I think it's 65.5. Do it right now, check out 65.5. 148.5, 75th percentile minus 25th percentile. And if you want to double check your work, go to the summary statistics, customize, and interquartile range, and you can cheat. Once again, found by here by customize summary statistics. So there it is, 65.5, but also understand conceptually, it is the 75th minus the 25th, and there's the answer. And the good news is, I think we pretty much have all the answers like I was saying. So this question right here, if you have jump, is there a way for jump to give the median? Yep, right here. Thank you for asking, Alexander. The median is 125, found right there. The 50th percentile is the median. 125 right there. We're throwing even more points. Keep asking those questions. Let me know what you're thinking. There's the median right over there. So the median is currently being displayed, and we will use these numbers. I'm going to decrease font size a little bit because I'm going to try to have it displayed on the screen as I'm typing them all in, so that way I can look at them and make sure I don't make an error. We're going to display the question over here. Move this over here. And there it is. The median is what? It is 125. The quarter one is 83. The Q3, which is 75th percentile, is 148.5. The range is the max minus the min. So 555 minus 31. You can do it in your head, and it's going to be 524. And then you can double check your work by cheating and going to customize summary statistics and click range. And there it is right there, 524. The interquartile range we already found is 65.5. It is 148.5 minus 83. And there's the answer right there. And we should have it figured out. This one usually gets, ooh, did I miss something? The mean. Well, we're not going to find the mean by hand. The mean is that right there, 2 decimals. So 134.24. And this turns a very tricky question into a pretty easy one. Because all you need to do is know how to use jump a little bit, and then all those values can be found for you. Double check your work by doing like max minus min, Q3 minus Q1. You show how to put the range. Yeah. Let's do it again. So to get those added to jump, you want to click the red arrow right here. This is where the options are at. Like this is the options button for this. Click customize summary statistics. Customize summary statistics. Under customize summary statistics, check the boxes you want, like range and interquartile range. I've also added skewness. I wouldn't click all these because it like corrected sums of squares, uncorrected sums of squares, autocorrelation. No, 3 standard deviation. Sure. Don't click all those. Then click OK right here. And once you've clicked OK, there you go. Does that make sense? Alexander, really great questions right there. More points in the chat for asking. And then find them by hand also to practice to be like, okay, the range is the max minus the min. Max minus min is range. The IQR is Q3 minus Q1, and there's the IQR. So know how to find them by hand also, and then you can use output to double check. Like we should understand theoretically the range is how far away are the biggest and smallest numbers, and interquartile range is how far away is the Q3 from the Q1, because it's just the range of the middle 50%. Conceptually understand it, and then use jump to get the right answers every time. Really good stuff right there. What's another one you want to do? This one's ones that stumps people, but it's really like if you have jump on your side, you got that question destroyed. It's an easy question with jump. I love it. Like it when technology makes our lives easier. Nice and easy one right here. We'll do the full quiz, but keep dropping those questions. People get stuck on this one. They're like, this is a hard quiz. And I'm like, let's do it. Let's ace it. And if you're in another section or another 207, 320, ask questions too. We'll do some R even. We've got a meteorologist. This one's very unique in its start. Preparing a talk. Okay. Meteorologist preparing a talk about global warming compiled a list of weekly low temperatures in degrees Fahrenheit he observed at his southern home last year. He's got 2 homes. What about his carbon footprint? One shade. The coldest temperature for any week was 36 Fahrenheit. But he inadvertently recorded it in Celsius, a value of 2 degrees. Assuming that he correctly listed all other temperatures, explain how this error will affect the center, the mean, the median, and the measures of spread. This brings us back to our earlier topic, and it's when do we use proper measures of center and spread? Or what are the proper measures of center and spread? Well, shape determines when we use mean or median, standard deviation, or IQR. And this is because if they're outliers, and let's write this, outliers drastically impact the mean and standard deviation. So this is a huge note. Outliers impact. So we don't want to use the mean and standard deviation when there's outliers because they are impacted by it. The mean goes in the direction of skew/outliers. So outliers/skew, or skew/outliers, skew/outliers. And so the mean goes in the direction of those. If there's high outliers, like this one right here, like here, we'll do some color coding on this. Let me go right there. So the mean and median on this one are virtually identical. And I'm speaking about the symmetric distribution right there. But the mean will go in the direction of the skew, as in the mean is higher than the median. That's a huge note to take. Definitely goes to test questions. But the mean follows the skew. The mean follows the outliers. So that's why we are often seeing an inflated value or average. We don't want to misrepresent the data by communicating things that are being pulled towards the extreme due to outliers. The standard deviation is a metric of spread, and the standard deviation is going to be inflated when there's outliers. So the standard deviation is standard deviation from the mean, typical distance, and we are going to see an increase to it. So extreme values or skew inflate standard deviation. So standard deviation inflated or gets larger due to skew/outliers. And median and IQR not impacted. This is huge right here. These are not impacted, and that's why we use them. So there's really good notes right here to take. That the mean goes in the direction of the skew or outliers. You can see it up there as I've drawn it visually. The standard deviation will be inflated. We'll see more spread in the data, and it's not really representative of the data. It's being pulled, or the data is being spread out more due to outliers or skew. The median and IQR are going to be not impacted because, think about this, the median is the 50th percentile. Outliers don't impact that because it's the middle person. Outliers are extreme. The IQR is the middle 50%, so the outliers are outside of that. That's why we use things that don't take into account the outliers, such as median and IQR, when looking at data that has outliers, so it excludes those. The mean will go in the direction, or the mean will be lower because this is a low outlier right here. See how this is way lower? He recorded the low temperature even lower than it should be, so it's going to pull the mean towards the low value. The median will not be affected. The range also gets affected because it's going to spread the data out more. Think about it's a new min, so there's a further away min that'll increase the range. So the range will be higher, there'll be a bigger range. The IQR will not be impacted because this is not part of the middle 50%. And the standard deviation will also be inflated will be higher right there. That's a really good question conceptually. Like just the conceptual knowledge of all this right here, really, really good stuff. So understand this, write down these notes, try to draw out some graphics to help yourself out. But there's the conceptual knowledge right here on the screen, and practicing this, understanding when certain values are used for center and spread and why we use them. So the way it works is standard deviation is a measure of spread. So the way, and good questions, Alexander, keep asking those questions. His data originally might have looked like this, and now it looks like this right here. So his lowest value got moved over here. Does that make sense? So standard deviation is a metric of spread from the mean. So we have distribution A and we have distribution B. Which one of these is more spread out, A or B? Which one of these is more spread out? All we did was take the lowest observation and move it further away. So which one of these is more spread out? One of these is a little more spread out than the other one. Because we took one observation, the answer. Which of these is more spread out? Bursts in 190 countries? You got it, Blakely, let's do it. Yeah, let's do it. B is more spread out because I know it's a lower value, but standard deviation is just a metric of typical distance from the mean. So if this is where the mean is at, things are a little further away on average because the lowest value is further away. Does that make sense, Alexander? Standard deviation measures typical distance from the mean, and by moving the lowest value further away, I know it's lower, but it's further from the mean. By making it lower, it's further out from the mean, spreading the data out more. Yep, and so this, if we drew it like another distribution like this right here, that'd have an even bigger standard deviation, more spread from the mean. Good questions. Let's go find that. Is the birth in 190 countries? Let's do that one. I think it's towards the middle right here. 8. Oh my gosh. Wow. Wow, wow, wow. And tell me if you have a different one. Sometimes there's multiple versions of these. I've been doing this quiz a lot. The accompanying, they're all the accompanying. Histogram, 190 bursts. Okay, let's do this right here. And this says describe the shape of it. Shape is the most important thing to understand. Mine only has 2 boxes. We'll do that one next. So yeah, we'll find it here, Blakely. Thank you, Blakely. More points in the chat. And I'll do this one, then I'll do the next one. We'll find the other version of it. So the first thing is shape, which determines center and spread. Ooh, what kind of monster man is this? Not that, he's not that kind of monster man. What kind of monster man we got going on here? If you get a test question like this, you got to ace it. You don't have to, but I want you to ace it. What kind of monster man we got going on here? Right to the high, left to the low, whatever way the monster man's tail goes. This is definitely a less skewed monster man. And because it's skewed, so I'll draw that right there, right to the high, left to low, whatever way the monster man's tail goes. Because it's skewed, what is the proper measure of center and spread? So we've got our notes. Because it's skewed, don't even worry about what they're asking yet. Because it is skewed to the left, the proper measure of center and spread will be what and what. If you learn how to do this without them prompting you, you're even better. Because it is skewed to the left, the proper measure of center will be this, and proper measure of spread will be this. Because it is skewed to the left, the proper measure of center and spread will be what and what respectively. Center this, spread this. What will be the proper measure of center and spread? Center is one of 2 choices, and spread, the center could be this, center could be this. What do you think is the proper measure of center and spread? We're throwing out points left and right. Go a moment longer, see if you'll get it. If you're watching along in the future, try to answer this, see if you know. After determining the shape, like it's left skewed, now we can talk about the proper. Oh, Alexander, let me throw even more points. So this is what I want you to do first when you get to these questions. Thank you for saying that, Alexander. Is I want you to first look at the shape and say, aha, Brian, that is a skewed distribution. And then the answers just follow down from there. Does that make sense? So because you determine the shape is skewed, you just go straight down from those answers. So what do you think the answers are now, Alexander? You got this. You say, oh, it's skewed. Because it's skewed, we want the things that are not impacted by skewness. The proper measures of center and spread will be what and what. Because you're going that path, not the normal distribution path. So because it's skewed, the proper measure of center and spread will be what? Median IQR, Alexander, 100 points of the office hours. You're just racking up those points. You got it. Yep. Thank you for saying I don't know. That's a great thing to say. Then I give more details. And basically, I want to show you how to use that information on the screen. We know it's skewed to the left. Now they're asking about How many modes does it have? And what, 70? And they're saying that's a mode at 76 or so and 80. So we see the two modes doesn't make sense because this is 64 to 66, and that would be in here. That's not really a mode. They're going one mode around 76, it looks like. So they're going right there for the one mode. Subjective if it has one or two, but it's not that there's a mode between 64 and 66. This is not a modal region. It would be either here and here or primarily here. And it depends how you make bin widths. All right, it can be bimodal a little bit. Here we go, is the other version. Thank you, Blakely, for saying this. There's another version of it right here. Let's do it. Now the accompanying histogram right here, and I think we have the same data. I love it because this is left skewed. Now say it with me again. The mean goes in the direction of the what? The mean goes in the direction of the what? In relation to the median. The mean goes in the direction of the what? The mean goes in the direction of the what? There's the note to take. The mean goes in the direction of the what? Right there, Alexander, great job getting practice. The mean goes in the direction of the monster man's tail, the skew, or the outliers. So the median is going to be higher than the mean because the mean is going to get pulled in the direction of the outliers down there. Monster man, his tail is pulling that mean downwards. So this, whatever it says, if it says which is higher, the median will be higher. If it says what will be lower, the mean will be lower because it's going to follow the skew and the outliers in that direction. Really good question so far. The mean goes in the direction of the skew is the thing to know to get this right so far. So the median will be larger because the distribution is left skewed. Monster man's tail right there, left to the low, right to the high. So he's got that left low tail right to the high. About 92% of my students, height, sure. About 92% of my students get a skew question correct. And I love that. And then the 8% that get it wrong, I just get really sad. I'm like, no. Oh. Choose the correct answer right here. What would you report, the median or mean? And Alexander, I bet you got this. Let's put our notes on the board. Would you, if someone said, what is the proper measure of center for this? Would you say median or mean? Oh, let's do that one next then. Yeah. Sorry, there might be a third version. I'll do that. We'll do this one, Blakely. You got it. So what would you report for this distribution? Remember we said it's skewed. What would you report for the center? You'd be like, you know, if I'm reporting the center, I'm going to report the what? No worries, Blakely. Blakely, 100 points. Keep asking. We're going to do it. We're going to do all of them. What would you report? The median, because the median and IQR are not impacted by outliers. The median is the proper measure of center for it. The IQR is the proper measure of spread. So I would report, and it might say both. I hate it when it says both. No, the median should be used because it's skewed. Should be right. Good deal. Sometimes they go a little wacky and they say like, do both. And it's like, okay, you can. Oh, wait, here we go. 2 blanks. Let's do it. The accompanying histogram shows life expectancy. It might be the exact same histogram again. It's that same monster man. Here we go. Report the blank. So now it wants us to say what should be the proper measure of spread for it. So now when we look at a distribution, this, follow me along, to determine the proper measure of spread, always look at the what first. To determine the proper measure of spread, first look at the what. Just remember this, like, just be like, how do I know which measure of spread to use? Yeah, Blakely, you're on there. Yes, yes. Yes, Blakely. You'll get to see it here. Look at the shape. Blakely, you're doing great right there. You looked at the shape. You saw that it's skewed. Since it is skewed, you're using the IQR because you said the distribution is skewed, median is the proper measure of center, and IQR is the proper measure of spread. So you did it perfectly. Report the IQR because it is left skewed, and that is your monster man right there. You got it. Excellent work, Blakely. Let's throw you another 50 points. Keep it up. Keep asking those questions. Good practice right there. We're just rocking and rolling. We just got 3 questions destroyed right here. Might be able to do the full quiz. Then I'll just say to people, every single question's in here. Join in, ask those questions, practice, 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 so you can remember like look at the shape to determine proper measure of center and spread. If it's skewed, median and IQR are center and spread respectively. If it's more normal, unimodal symmetric, then the proper measure of spread will be the mean and standard deviation respectively. So like once you say it a few times or visualize it or write it down, you get better at remembering it, and then you should understand the why behind it. And it's because the measures of mean and standard deviation are impacted by outliers. One of the questions went over that. And the median and IQR are not impacted by outliers and skew. So they are the proper measures when we have extreme values or skewness, which is a pole in the distribution. We've done a lot. Let's see here. Let's go back to question 10. Ask another question if you got it. And we do all the questions during office hours. They'll be so happy. They'll be like, oh my gosh, the video has every question. Every single one. Chapter 2 quiz. The U.S. Census Bureau. Chapter 2 quiz. Okay, so we got another distribution right here, and it wants us to know which will be larger. Now remember, skew, a pole on the tail or outliers, are going to impact the mean and median. The mean follows the direction of the skew. That's a huge note that you need to put on a note card and remember, because just imagine I do this. I give you the numbers 1, 3, 5. The mean would be 3. 1, 3, 10. Now the mean's going to be larger. It's going to be 14 divided by 3, so 4.66. And then we get 1, 3, 100. Now it's 104 divided by 3, so that's going to be 34.66, I think. And so you can see the mean gets larger because of the extreme values. Let's see what's going on with this data right here. See which way. Oh, that monster man. Let's look at this monster man. So here's our monster man. Right to the high, left to the low, whatever way the monster man's tail goes is what we need to know. Monster man is looking like this right here. He's got some extreme values over there. There's the monster man. There's the monster man's tail. Now, because it is skewed to the right, we're going to see the mean follow the skew. So the mean's going to be up this way. And we're just estimating. Sometimes people say, how do you know that? And I say, well, it's just a guesstimate. And the median is going to be down here. Because what the median would represent is 50% of the data is going to be below here. 50% of the data is going to be above here. The top 50% of the data is stretched out in the high direction. So the mean is going to be a bad representation of the center because it's going to be pulled in the direction of the outliers or the skew that Monster Man has. Remember, right to the high, every time we say high, we're talking about the right side, the higher numbers, left to low, whatever way the Monster Man's tail goes. I know I say this a lot, but you won't forget it when it comes to the test. And so what would you expect to be higher? The mean, because it's pulled in the direction of the skew and it's skewed to the right. So the mean will be larger because it's skewed to the right. So the mean is pulled in the direction of the skew. It is pulled towards the higher values. Very good conceptual knowledge right here. Choose the correct answer below. Would you report the mean or median? And you would definitely report the median. So I'm just going to click this answer for now. We'll look at the other ones. Well, just says, that's the only one that says report the median. So yes. The reason I know that is because the proper measure of center and spread. Let's do that one next. If we get 90 or higher on the my Pearson assignment, says it make it 100. You might be thinking of another class. I've done things like that, not for us right now, but it doesn't turn into hundreds. Alexander, good question right there. And get this to where you can just like ace these assignments and do them super quick. You got 5 attempts, and just remember, it's like practice. Frankly, I think the best strategy would be to take it 2 days early, get a good grade or ace it, and then take it the day of and ace it again. Because it literally is just like cementing that knowledge down, and then you have less review when you get to the test. Because you're going to review when you get to the test anyways. You're going to be like, I got to review this stuff. I got to refresh my memory. So the more you refresh your memory and the quicker you can do it, it's like, you know, picking up a weight and getting stronger. You're going to train your brain to know the topics by just reviewing them. So I would do it 2 days early, and then maybe just, because I can do these quizzes in, I'm going to do a speed run here in a moment, but I bet I could do this in under 7 minutes. We'll do that. Should we do that, Alexander? Or should we, Alexander, let's do a vote. Start a poll. All right, here's the poll. Speed run in under 7 minutes or do the quiz slowly. We've done a lot of questions today, and I like to break it up and do different things. But you're like, no, just, winning. Speedrunning's winning. Might do it right after this one. How quickly? I got my timer down here, so I haven't used the timer in a while. So where's my timer? I don't have any more. Oh, we got 3 or 4 people watching. Speedrunning's winning. Take a vote before I finish this question. Let me mark it, and then if speedrun's winning, we'll do it, or we'll tie break towards speedrunning, because I want to speedrun it for fun. Let's see how fast. Okay, Stat 201, Chapter 2 quiz. That's Excel with Winston. Oh, it is? Oh, that's really nice of him. Thank you for doing that, sir. Study on body fat. Yeah, you were thinking another class, but that's all right. We'll throw you some points for shout outs to the other teachers. Here's the data. That looks pretty. Data's not perfect. You got to be nice to data. It tries its best at times. You know what? This data tried its best to be normal, and it's a dot plot. Dot plot is a quantitative display of univariate data. It means we collected one variable, and you know what? Let's get a little more data right there. It looks normal. That's pretty darn normal. We're looking for things that are drastically different, like the monster mens we've been seeing before, and I'd say this is pretty darn normal. So should we use the mean? Should we use the median? And I think this is the one that says both. Not a huge fan of it. The mean is probably fine. You can also do the median, but because it's pretty symmetric, both values are going to be kind of close to each other. You can let the reader decide. The mean is what I would say to report, though. In Stat 1, nice job. Everyone's helping each other out right here. Throw more points in the chat for all the convo. You can report both. I dislike that this one's like, oh, report both, but I've done it a lot. And so it says like report both. You definitely wouldn't want to, it might just say the mean right here. That's kind of a right answer too. And frankly, if you answered this and it's the only one you got wrong, email me if I'm your teacher, or tell your teacher. I don't know. It's their call if they want to change it. I think it's a little mean because I know I've clicked this one. I was like, there's one of these that's like report both. Report both. The distribution of biceps is unimodal symmetric, so the mean and median should be very similar. Yeah, but then just report the mean because, yeah, and then you could say the median's close to it. I don't know. Anyways, let's do this speed run of it. Okay. Let me get the speed run going. Time for a little hacker man right here. Stats 1 hacker man. We got this. Blocking my own logo. Didn't even do the logo properly. There we go. Where's my hacker man logo? Very important. Yeah. Yeah. Let's do this. We're gonna hack the statistics away. Where's my timer? I don't even know where my speedrun timer's at. Live split. I need to get the new live split. Okay, my live split timer is not the way it used to be. Okay. Lost all my cool stuff to it. Out there, everybody. Wait for my Pearson to load. Oh, my Pearson. Yeah, we do the homework next after this. Caroline, you got it. We're gonna speed run Chapter 2 quiz. It's what people voted on. Then we do the homework. I hit replace question again. We're speed running the quiz. Let me mark that in the thing. Stat 201. Chapter 2 quiz, speed run. Mid the quiz, so that's perfect. Oh yeah, so we're speed running it. So here's the thing. I'm gonna try to do this in under 7 minutes, and then we're gonna go back. If you have a question that you want done, let me know and we'll do it next. But I'm gonna speed run this because I said I could do it in 7 minutes. So we're bringing it over to the main screen, and we're gonna try to do this in 7 minutes, and then please slow me down after this and tell me which ones you want to do after this. So here we go. Time for a Stat 201 speed run. Here we go. Let's do this. Oh, hey, right, this is a speed run, so we're gonna do it quickly as we can. Let's do it. Time started. We've got the NFL right here, or Gretzky. This is a stem and leaf plot. His lowest was 445, and his highest was 82. So use the mean or median. It's very skewed, so use the median because the distribution is skewed. It's skewed to the left because these are low numbers. Be very careful. Low side skew, that is the median. Find the median. Oh my, I got a tough question to start. 20 seasons. So it's the average of seasons 10 and 11. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Luckily, it's in between those. So it's 79 is the median, is the middle number. With actually finding the mean, which would you expect to be lower? The mean is going to be lower. Which you expect to be higher or lower. The mean will be lower because it's going to be pulled in the direction of the skew, and it's skewed to the left. That's the first one right there. Done. And then going on to the next question. The shape of the distribution is skewed to the right. It is unimodal, skewed to the right. So right there. Next question. And we have right here things like this. This is, let me decrease font size. That is super unimodal symmetric. That is as unimodal symmetric as it comes. They have close to, where's the center? Center is about 13. The center of the distribution is about 13. Most are between kind of one standard deviation, about 11 to 15. So 12 to 15 is good. I said 11 to 15. But there is R as small as 10. There are how many as small as 10? Oh my gosh. Gotta count the dots now. 1, 2 as small as 10, and 1, 2, 3, 4, 5 as high as 16. So was it 2 and 5, right? Don't want to make a mistake. 1, 2, 1, 2, 3, 4, 5. Okay, as long as I'm not reading it wrong. There we go. And now next, we get right here a pie chart, it looks like. Here we go. What does it want to know? Pie chart, bar chart, ways to display categorical data. The least common rating was the one with the smallest little bit. It is G, doesn't even exist on this. So G is not even there. It's easy to see this question from the bar chart because you don't even see it. It's easier to see from, yeah, actually, it's easy to tell from either chart because the rating count is so low to compare the counts to the other ratings. That's probably it. I'm a little worried. Yeah, because it didn't exist. Usually bar charts are better. Oh my gosh, we're getting long questions. Oh my gosh. Which pie chart corresponds to year 1? Oh my gosh, this is a lot. Which pie chart corresponds to year 1? Okay, so year 1 is a lot of R, it has RG, and then RG are the primaries. So this is a lot. R and G are the primaries, so it looks like B. Year 2, it is, these should be even. Yellow and red should be even. The yellow and red even, that's A. They could have put those in order right there. Year 3, kind of goes down, but there's a little green. So it goes tons of yellow. That's easy to see. Tons of yellow. That's going to be C. About halfway done. And then year 4, that is moderate yellow. So it's D. Man, that's hard. It's hard to display that. I don't like that. Okay, we got another distribution with some right skew over here and a little bit of an outlier. The middle 50%, that's what the IQR is. It's the middle 50%. On average, movie lengths varied from the mean. That's what a standard deviation is. Standard deviation is different variation from the mean. Since the distribution appears to be a little bit right skewed, it's got a little bit of skew. And there would, since the distribution appears to be skewed to the right, there would be concerns about using these descriptions for these data. The standard deviation is misleading. If it's skewed, I'm right. Yeah, skewed. A little bit of right skew. It's not that strongly skewed, but a little bit skewed. This is the skewed data. No, this is pretty normal. Since it's normal right here, we are going to use the standard deviation because it's mostly symmetric right there, mostly normal. That's got that one. How are we doing on the questions over here? This is the last 2. Okay, so report what? You can report either. We did this one earlier. Report both. Let someone decide which one to use. And then last but not least, okay. What is the center and spread for these data? This is normal data, so it'd be mean and standard deviation should be used. Right there. There we go, mean and standard deviation. And boom, sub 5. We did it. Woo! What are we gonna do next? Lost my voice right there. Woo, maybe that's what I'm talking about. Wouldn't the university one be bimodal, skewed to the right because of that one little bar all the way to the right? Let's go look at that one again right here. Let me close live, split out. Close all windows, yes. Oh my gosh. Here we go, close all windows. Close all windows. Go. Let's save. Traffic Fatalities with 8 parts ABC, let's do it. Okay, wouldn't the university one... Which one? Do you remember what number it was? Do you remember which number it was? A university teacher? Oh, that's extremely right skewed. Wouldn't the university one be bimodal? Oh, so this little bump right here, always think about it as mountains. And would you call this tiny little bump over there a mountain? So would you call this tiny little bump over there a mountain? Does that make sense? If you think about these as mountains and you're going to go out and like climb a mountain, then would you call that tiny little bump over there a mountain? That's the way to think about bimodality. Things that are bimodal have strong mountain peaks, and the more stronger the mountain peak, the more bimodal it is. So there it is right there. So this isn't really bimodal. Bimodal might be something more like this right here is more bimodal. True bimodality, or easy to see bimodality, looks more like this. So this is the point when, sure, it's bimodal. And this is where it's definitely bimodal. And then down here, it's like, nah. Does that make sense, Alexander? Like, when we talk about bimodality, you want to see a clear kind of modal region where there's a concentration of data. This is kind of the break point. Now, it's subjective when it's bimodal, but a little outlier over there we're not going to say is bimodal. Alexander, you're asking some top questions right there. Bimodality is a subjective term. The stronger the peaks are, the more we can say it's bimodal. But one outlier we wouldn't usually classify, or that could be 2 or something. I'm looking at how high the bin is. Just that little data out there, we wouldn't probably say. Very few statisticians, I think, would call that bimodal. And thank you so much for asking these things. Really good questions. Traffic fatalities, let's do that one. You got this. Practice these quizzes, know how to do them. Fatalities next. Practice, practice, practice. We got a pretty good version, I'd say, too. I could have had a jump version. Oh, I lost which ones I've done now. So we might be repeating questions, but that's okay. We haven't done this one because I haven't seen this lately. Okay, so we're gonna do the traffic fatalities one. You can do it. There we go. My background back up. Okay, traffic fatalities. My Pearson is like doom and gloom. Okay, got it up, got it marked. Let's do it. The accompanying histogram shows the annual numbers of traffic fatalities and passengers in a car. One plot's the year and the other plot's the fatalities. A group of fatalities has been highlighted, and the corresponding bars in the years have been highlighted also. So we've kind of got two distributions, one for years and one for fatalities, but they're not doing a bivariate. They're going to show us 2 histograms right here. 2 histograms. Well, that's just the data. There's the data, what it looks like. You can see it goes down, which is good, only to 2013. And here's the data. We've got these bars right here representing these years. Now there's gaps in the data where they didn't collect. Years uniform with gaps because they didn't collect data. There was no data collected for 1976, 78, 79, and then 81, 82, 83, 84, 86, 87, 88, 89, and then it's uniformly collected across. Uniform means flat. There's mostly uniform data with gaps. Then down here, this is slight bimodality, Alexander, sorry. Alexander, this is very slight bimodality. Some statisticians might not even say that. They might say there's a little bit of outliers down here. I'd call it slight bimodality. The years with the highest would correspond to the data up there. So you can see the high, these are the years, 1975 and 1980 have the high fatalities. You can also see that looking at the original data right here, that the years 1975 and 1980 have the highest, and then there's a trend going downward that more modern years have less traffic fatalities. Let's hope that that's true, but with cell phones, I fear it's not. Please do not mess with your cell phone while driving. Use only hands-free devices and focus on the road. How many years are included in the highlighted bars? So we have to type in the years by name, and how many years are included? Okay, we just type in 2 years, just 2 different years. Your parts, let's do it. We'll find that one, Blakely. Let's do it. We'll do this one, then we'll do the next version of it. Which years are included? Separate with a comma, 1975, comma, 1980. Oh my gosh. 1975, comma, 1980. What did these histograms taken together say about it? What did we say? We said one of these. The total number, there have been fewer passenger car fatalities more recently than there were. I think that's got it. Boom, we've been on a streak today. Sometimes I get something wrong. Might be this one right here. Is this it? We will find it. You'll find it. Thank you, Blakely. They don't get too innovative with their questions. They come up with a lot of the same questions. Tell me if you see the number, Blakely. So if you see the number, those traffic fatalities. If you're like, oh, number such and such. It's 9 for you. Oh, then it'll be towards the end for me. So you get them in a similar sort of order. I don't remember this one right here. That's just going to be an outlier in the data set. Oh, is it this one? Party says fatalities histogram. What? How does the question start again? Party says fatalities. If you see it, let me know. See it. Let me look at the very start of it again. Traffic fatality. What's the very start of it say? Like what's the very first words say? What is the very first words of the question? Like where it says up here, like this right here. I'm looking for it. Yeah, if you put the very first words of it in the question. It said traffic fatalities again when I saw it in the other preview. Maybe no, sometimes there's different versions. So Blake, what does the very start of it say? The accompanying, okay. Thank you. There's so many of the accompanying. Like all of them are like the accompanying this, the accompanying that. If you see the number, let me know. Blood deaths. If you can post it on Discord too. I'm gonna take a screenshot. Not flood deaths, is it? Wait. Tornado. Does this one change actively when you do it? No, it's still tornado every time. Questions will change. Doesn't say the accompanying also. Where is it? Not this one? It's not this one right here? Yeah, well, and which one? It's not this question though? Traffic fatalities. Oh, is it in the homework maybe? Bailey, is it Blakely? Sorry, Blakely. Is it on the homework? Homework might have a question this doesn't. Is it a homework question? I can do the full homework because we haven't done the homework yet. So we've done a lot of this. I just have a guess that maybe it's the homework because that would explain why I'm not seeing it. Might be question 9 on the homework. Oh, I think it is. No, this is a different one. Let me see. I do the full homework real quick. Okay. No worries, no worries. Sorry I couldn't find it. Let's do the full homework here real quick because we're 30 more minutes. So sorry about that. Yeah, send me a picture of it too. Oh, I can't find it. So 128, 53. Drop more questions. I'm sorry I couldn't find that one. Chapter 2, homework, full solve. Okay. So this first one right here is a pie chart. A pie chart is a display of univariate categorical data. Take a picture of this if you don't have it, so you know which graphics to use and when. We're talking one categorical variable. We're talking pie charts. I prefer bar charts. There's no other variable on the other side. Remember how to use this graphic to know which graphics to use and when. Now right here with this graphic, we want to know, is this an appropriate display of the data? Well, yeah, it is, and they give reasons. Things can't overlap, but pie charts are a display of categorical data, univariate. What was the least common? It's gonna be a little blue sliver of NC17. And that's it for that question. A university teacher saved their emails from students. He then counted from each student who had sent him emails at least once, how many emails the student had sent to them, and here's the accompanying histogram. Now this is a monster man if I've ever seen one. This monster man is skewed to the right. Right to the high, left to the low, whatever way the monster man's tail goes. So we got monster man right here, a little bit of an outlier over there, and we have the high side, which is positive right skew, right to the high, left to the low, whatever way the monster man's tail goes. So don't forget that right there. Right skew, positive skew, high skew, higher numbers. That's what we're talking about with monster man when we recite that, to remember what way skew goes. So this is going to impact the mean. The mean follows the direction of the skew. So if you have the mean, it's going to be inflated, hence we wouldn't use it. The median is going to be the proper measure of center because the median is not impacted by skew or outliers. The first thing we do when determining the shape of a distribution is to look to see if it's skewed, has outliers, or things like that. It might be unimodal symmetric, and the more symmetric it is, we use mean and standard deviation as proper center and spread. This distribution right here is very skewed, so the shape is skewed, so it follows the proper measure of center as median and the proper measure of spread as IQR. Make sure to have these notes right here, write them down, I'll disappear, but a lot of good notes on the screen on what happens, and it answers a lot of these Mike Pearson questions and a lot of test questions too. So here we go. The histogram is it's unimodal and skewed to the right. The histogram is skewed to the right. Is more common, does not say unimodal, skewed to the right. It's most common, not 4 to 5. 1 to 2 is most common because that's the concentration of data down here. 1 to 2 emails is pretty common right there. Next we have describe the shape of this distribution. Let's talk about it first. This is left skew. Once again, monster man right here. Take a look at the data. Gonna have some left skew to it. So we go right here and we can see monster man's got some left skew right here, meaning the tail is to the low side, right to the high, left to the low, whatever way the monster man's tail goes. So with this, it is skewed to the left, to the low side. And so where's the center of the data? There's really one central area. There's a second mode in here. If we were to say like around 76 and around 80-ish, I'm just going by this would be 80 and this would be 82 if you go up the number line. 76 and 80, and there is only one answer that works for this because it's not in the 60s. So because they're saying it's one mode, the two mode idea just doesn't go across. It's subjective a little bit on when there's two modes. This is mostly unimodal with a little bit of a second peak near the high numbers. If we were to talk about it being bimodal, we'd say a concentration in the upper 70s and the lower 80s, but there was no answer on Pearson that corresponded to that. So the concentration is around, I'd say, the upper 70s. It also depends if you change the bins, because if the bins are changed, the data might just look like that right there. Changing the bins changes the way it looks. It doesn't change the data, but you could bin this up differently so that the data might be binned more like this, and you would just see one bin right there. So just make the bins larger and collect more data in them. So it doesn't change the data, it just changes the way we like visualize it, which is still the same data. Here's another accompanying histogram. And it's the same histogram. So what would be larger? Well, we already talked about this a moment ago, because when we were talking about it, the mean follows the direction of the skew, and that's a huge note to take, so write that down. Mean follows the skew, so the mean's going to go towards the monster man's tail, which means what would be larger? Well, if the mean's going towards monster man's tail, that means that the median is going to be larger, because the mean follows the skew. So the median will be larger because it's left skewed, and the mean will be pulled in the direction of the left skew. Choose the correct answer. Which one of these should we use? Well, this goes back to proper measure of center and spread, depending on if the distribution is skewed or more normal. Since the distribution is more normal, or no, it's not more normal, it's more skewed, I've got the right thing circled, we'll use median and IQR for center and spread respectively. Some notes are down below to cover the topics. So the proper measure will be the median because of the skew. So it's the proper measure of center is the median because of the skew. And once again, try to answer these without looking at their answers. Then you really know it by being like, oh, it wants to know the proper measure of center. Well, it's skewed, so we should use the median. Another student surveys members of his student class and finds that the balance on their credit cards is strongly skewed. He would be better off reporting which statistic of a typical balance of their credit card. Well, it's skewed. So shape determines center. Center is either mean or mean or median, and since it's skewed, median. Once again, the notes we've written down here is the answer to the question that if you determine the shape and it's skewed, the proper measure of center will be the median. So once again, these notes are a huge help, and the median is going to be the proper measure because of the extreme values and the skewness of the data. Now we get a shape right here of data, and it wants to know, should we use standard deviation or IQR? Let's slow down here for a moment. Standard deviation and IQRs are both measures of what, along with range. Now, we don't often use range. You can if you want. Range is going to be highly impacted by outliers too. Standard deviation, IQR, and range are all measures of what the data is. The answer is spread out. All of those right there, standard deviation, IQR, and range, are all measures of how spread out the data is. What is the proper measure of spread to use? This depends on the shape. So if it's skewed or has outliers, IQR. If it's more normal, standard deviation. That's SD right there. And so now let's go look at the shape of it. And the shape of it is skewed to the left. Once again, we got to draw our monster man here for practice. There it is already, monster man. Now, when it's skewed, it's going to inflate the standard deviation because it's going to spread the data out more, making the standard deviation not so reliable. So report the IQR because it's skewed. Really good answer right there and really good practice. Good stuff. Next one we see is the question says, would you report the IQR or standard deviation? Once again, look at the shape. What's the shape of it? That looks pretty normal. Now, I know it doesn't look perfect. And this is bicep size, which is quantitative data. There's Mon, 25, boom. So bicep size, quantitative data. And we go right here, we draw over it. We don't really get a good monster man, I'd say. Like this monster man is looking kind of like a dual monster man. You don't know which way his tail goes. He's a very duality of monster mans. He's thinking, I got two tails right over here, but he doesn't really. He's mostly symmetric. I know there is this little bit of weirdness. He's got a Monster Man gap right there. But that's all right. Nothing perfect. You did all right, Monster Man. So when we have a mostly symmetric distribution, mostly symmetric because nothing's perfect, and it doesn't have extreme outliers, then the proper measure is going to be the standard deviation. Standard deviation is the proper metric of spread when the data is mostly symmetric. Next, we have right here speeding tickets, and this is a really good conceptual one. It's a tougher question, but you have to think, how would this data look? Speeding tickets. Think about how many you've gotten in the last year. Hopefully 0. I've gotten 0 too. Thought I was going to get one this morning. Haha, I didn't get one because I was like, I'm going to pass this guy. Oh, look, there's a cop. Oh, right when I try to pass somebody and go 5 over. Haha, I didn't get a ticket. Yay. But there's probably people who get a lot of speeding tickets. So you're gonna have a lot of 0, 0, 0, 0, 0, and then you're gonna have a bunch of people getting a lot of speeding tickets. Or not a lot of people, but there's gonna be people on the high side over here. So we got a right skewed data set. So it's probably gonna be unimodal with all the zeros. It's probably gonna be skewed because a lot of people are gonna get 0, 1 with a few large values, people getting extreme, like a lot of tickets. This one I always get wrong because I don't know golf so well. So you're gonna see me get it wrong. Maybe we're gonna lose our streak of the day. We're gonna try right here. Let's see what we do. The player's scores in strokes in a golf tournament. Well, there's a lower limit. You have the lowest golf score you could ever get is 18, and you get that, you're amazing. No one's ever gonna get that. Say that, and then Tiger Woods gets it. The upper score is pretty much anything. I'll get that, 1 billion. I'm still playing that game of golf that I never finished. The distribution of scores would probably be bimodal. Like some players do good, some players do bad. And maybe have a right skew where people are doing worse. I hate this one. So bimodal and skewed. So let's see. This is where you have to make sure it coincides with your idea. Most scores will either be very high or very low with few golfers in the middle. That's bimodality. Every golfer won't have a different score, so that's an impossible answer. More golfers will score above the mean than below. So then that would indicate a skew also. That's impossible. The only ones we can possibly have are either this one or this one. Everyone can't score above the mean because it means the average. Every golfer will have a different score, possible theoretically with like 5 golfers, but there's a lot of golfers in the PGA. So more golfers will have scores above the mean. So more golfers having scores above the mean would be a unimodal right skew. Most scores will either be very high or very low with few golfers in the middle. I hate this question. I hate this one because I don't know golf. You know what I'm gonna do? I'm gonna get mad at my peers when I do this. Like, did player scores US Open Golf scores histogram? We are literally Googling histogram of. They're not really showing up. Golfdata.com shows. Okay. Here's what I'm seeing. Unimodal skewed right. If it's skewed to the right, players would be below the mean. I hate this one. Every semester I hate it. I'll give you points back. I'm gonna go with what I thought. Right here. Nope. No, not uniform. Where's unimodal? Unimodal, skewed. I hate that question. Weights of female babies born in a particular hospital over the course of a year. Probably gonna have people either, a lot of babies are gonna be towards the middle. So it's gonna be more unimodal and probably skewed. Everybody will have different weights than possible. That's very uniform. Some babies will be much lighter than the rest, skewed. Most babies will have an average weight with about the same number of babies lighter and the same heavier. That sounds right. So let's go with symmetric. There we go. I love this question. Oh, I clicked uniform. Oh my gosh, I can't read. I'm losing it. I had my streak. You lose a streak, it's all over. I clicked uniform. Uniform is flat. I was going for unimodal. So no, I was going for unimodal. That one's on me, or I didn't get it early wrong. 100 points if people are still watching. The length of the hair. I do like this one though, because there's a lower limit on how short your hair can be. You could just shave off all your hair, but there's really no upper limit on how long your hair can be. And then either people usually have kind of very short hair or they have longer hair. So there's going to be 2 modal areas. This is true bimodality. I do like this one. And it's probably going to be skewed because people can keep growing their hair out longer. You're going to kind of hit, if you talk about the way the data looks, a lower limit of your hair just not being there, and then you've got like here you can just keep going on growing your hair out longer. So you've got, if you think about who this is over here, this is just person with shaved, like no hair, and then over here you've got person with medium or pretty long hair, and then as you go further and further out, you're going like really long hair, like super duper long hair, and in here you've got like the hair that's kind of, I don't know, this hairstyle is like coming back into style. got like this, which not everybody has. Like, I guess I often have this hairstyle, so that's me being the odd person in the valley of where you don't usually see hair lengths. And so you get this bimodal distribution with a right skew nature to it because there is no upper limit to length of hair. This one's pretty good, and it makes sense on how it works on the answer, as I probably get it wrong. I won't get it wrong. Skewed because yeah, can't have negative hair. So there's the answer right there. If you didn't see it, I'll show it again real quick. But there is no lower. There's the answer here. Men and women have different distributions. But once again, I've had my hair to my shoulders, and anyone can shave their head if they want, or whatever they want to do. So different distributions generally. Say generally, Matt Pearson. There's, well, I guess that's modal areas. Like, yeah, it's a generality, concentration of data, generally. And let's do the next one. This one right here just is the percent of accidents that occur or fatality reasons. It is it reasonable to conclude that respiratory and heart were 29%. We need to go here to respiratory is 5.7, heart is 23.4. So now we go in and we do 23.4 plus 5.7 and approximately, yes. It says there's no possibility of overlap, just what they record. I don't like the way they phrase that. What was not listed here, so the table has to add up to 100%. And so we just take the numbers, 23.4, 22, 5.2, 5.7, 5.4. That should be all the numbers, 100 minus, and then we drop the number in here and we should get it right. It's just the remaining percentage is missed. Now we have to graph it visually. And one of the best things to do with this graphic is just to look to see which one has the other and the other has it. And that's the remaining 28.3. And if you are doing this on a quiz, look to see if that looks like about a little more than a third, which it does. Actually looks way more than a third, but you can get probably an estimate or a guesstimate on your answer. Well, really good work, everybody. We did a lot today. Hopefully people use this right here to do the questions. Over to the main screen. Might take a short break, go on a walk, grab some lunch. A lot of stuff going on. We're going over strong, moderate, and weak correlations so we understand how to interpret them. Little do they know, I love this. We say here, weak. Awesome. Well, I'm hearing my students in the winter May term talk about it. Yep. Let's do Canvas content end. I got a little more time. Canvas content. Let's do some Canvas content. Oh, it's right there. Canvas content. We already did. February 5th is due. Too soon. Too soon. No one's gonna see it. We'll do it in class, or we'll do it live. Do it next time. It's the last office hours of the week. Oh my gosh. Well, until next time. Bye for now, everyone. Bye. We've almost got these new intros ready. We're almost there.
This has been going for like 20 hours. This ends now.